Today we are in unit number 3, that is the motion in a straight line. Before going into the actual topic, let us understand what is mechanics. Mechanics is actually a branch of physics which deals with the study of motion. Mechanics has been classified into two branches. One is the dynamics and another one is the statics. Dynamics deals when the body is in motion, whereas statics deals when the body is at rest. When do we say a body is in motion? A body is said to be in motion if its position with respect to the surrounding changes with time. Let us look at an example. In this example, you can look at the position with respect to the surrounding changing with time. So when do we say a body is at rest? A body is said to be at rest if its position does not change with time. Just look at the example of a still photograph of moon. The position of the moon is not changing with the time. There are three kinds of motion. Number one, translational motion. A body is said to have a translational motion when it is moving along a straight line. You can just look at the beautiful example of a train moving on a track in a straight line. Number two, rotational motion. A body is said to be in rotational motion when it is moving in a circular path. Look at the example of motion of wheels of vehicles. Number three, oscillating motion. A body is said to be in oscillating motion if it moves to and fro from a main position. Look at the beautiful example of a swing. You can see to and fro from its main position. Main position is the position where the body was initially at rest. There are three types of motion. Number one, one-dimensional motion. When a body is moving along a straight line, it is said to be in one-dimensional motion. You can look at the example of a car moving on a straight road as a very good example of a one-dimensional motion. That means the car is moving only in a one axis, that is x-axis. Number two, two-dimensional motion. When a body is moving in a plane or a curved path, it is said to be in a two-dimensional motion. You can look at the example of a man skating on a sea. It is a very good example of a two-dimensional motion because it has a two axes. One is x-axis and another one is a y-axis. Number three, three-dimensional motion. When a body is moving in a space, it is said to have a three-dimensional motion. Let us look at an example of an aeroplane taking off from the runway. Here you can see X, Y and Z axes. So this is the best example of a three-dimensional motion. So let us look at another beautiful example where the man begins to start is the initial point. In terms of physics, it is an initial position. He walks for some distance. The point where he ends is called final point, or in terms of physics, it is a final position. Let us assume the length from initial point to the final point is 25 meters. So this is called a path length. Then how do we define a path length or a distance traveled? It is the total distance covered by a body during its motion. Since we have written a 25 meter and we are not bothering about the direction, it is a scalar quantity. So let us look at another example. When the car begins to move, that point is called the initial point. In terms of physics, it is the initial position. The car is moving up to some distance. The point where the car stops moving, that point is called final point. In terms of physics, it is a final position. Let us assume the path traveled is 500 meters. Obviously, this curved path is called path length or the distance traveled. But what do we mean by displacement? So displacement is the shortest distance between an initial and final position of the body during its motion. That means if there is a straight road from initial point to the final point, definitely it would have been the shortest distance between the initial position and the final position. So this is called displacement. So let us assume that the distance of the shortest path is 350 meters. But here one more important thing we have to note is the direction. 350 meter towards east direction. We are actually specifying the direction. Thus displacement is a vector quantity. Then what are the differences between a displacement and the distance? So in distance you can see only 25 meters. So here there is no specific direction. That means it is a scalar quantity. Whereas in case of a displacement, you can see 350 meter towards east direction. That means it is specifying the direction. Thus, displacement is a vector quantity, whereas distance is a scalar quantity. And also you can see that in distance it is dependent on the path, whereas displacement is independent of path. And also you can see distance is length of the actual path, whereas displacement is the change in position. So let us look at another example. The point where the man starts walking is the initial point. At this point, I will start the stop clock. The man walks up to a certain distance. The point where he stops walking is the final point. At this point of time, I will end the stopwatch. Let us assume the path length covered by the man is a 25 meter, and to cover 25 meter, he has taken approximately 8 seconds. So what is speed? A speed is calculated as distance by time. What is the distance covered by the man? It is 25 meter, and the time taken to cover 25 meter is 8 seconds. So 25 meter by 8 seconds gives us the speed. Speed is equals to 3.125 meter per second. How do we define a speed? So speed is the rate of change of position. We can see there is no specific direction, thus it is a scalar quantity. Let us take the same example again, but here the man starts walking up to a certain distance, let's say 9 meter. So to cover a 9 meter, it took 3 seconds. Again he starts walking for a 5 meters, and to cover a 5 meter, it took 2 seconds. And again he starts walking for up to 11 meter. To cover the distance of 11 meter, it took 3 seconds. So what is the average speed? Average speed is equals to total distance by total time. So total distance is equals to 9 meter plus 5 meter plus 11 meter by 3 seconds plus 2 seconds plus 3 seconds. So average speed will become 3.125 meter per second. Then how do we define average speed? Average speed is the sum of a total distance by sum of time taken. Once again, let us look at the same example, but here the man starts walking from the initial point, but he stops walking at a particular instant of time, let us say 3 seconds. So the total distance covered up to 3 seconds is 9 meter. So what is the instantaneous speed of a man at that point of time? So instantaneous speed is equals to distance by time. Distance covered from initial point to that particular instant of time. That is a 9 meter by 3 seconds. He has taken a 3 seconds to cover a distance of 9 meter. So instantaneous speed is equals to 3 meter per second. At that instant of time, the speed of man was 3 meter per second. So next concept, velocity. Again, let us look at the same example of a car. Here, initial position is the position where the car was actually at rest. So as I earlier told that if there was a straight road from initial position to the final position, then it would have been obviously the shortest path between the initial position and the final position. Let us assume the displacement between the initial and the final position is a 350 meter and the direction is towards east. So what do you mean by a velocity? So velocity is equals to displacement by time. It can also be written as dx by dt. We know displacement is equals to 350 meter and the time taken to travel a 350 meter is just 7 seconds. So 350 meter by 7 seconds. So velocity is equals to 50 meter per second towards east. So velocity is nothing but the rate of change of displacement. Since we have a direction, it is a vector quantity and the SI unit is meter per second. So next concept, average velocity. Again, let us look at the same example. So initial position is the position where the car was actually at rest. Let us assume that the car moves up to a certain distance, let us say 100 meter towards east. That is from point O to point A. Again from point A to point B, it travels 200 meter towards east. Again from point B to point C, it travels 50 meter towards east. So what do you mean by average velocity? Average velocity is equals to total displacement by total time taken. So we know total displacement is 100 meter plus 200 meter plus 50 meter. And the total time taken is 5 seconds plus 7 seconds plus 2 seconds. So the average velocity will become 25 meter per second towards east. So what is our instantaneous velocity? So let us assume that the car starts at the initial position and starts traveling up to a certain distance. At a particular instant of time, let us say it has traveled 100 meters towards east. How do we calculate the instantaneous velocity at exactly this point? So it can be calculated as instantaneous velocity is equals to dx by dt. So dx is the displacement and the displacement is 100 meter. By time taken, it has taken a 5 second to travel 100 meter. So 100 meter by 5 second. So instantaneous velocity is equals to 20 meter per second towards east. Then how do we define instantaneous velocity? It is the velocity of the body at a particular instant of time. So what are the differences between speed and velocity? Since speed has no direction, it is a scalar quantity, whereas velocity has a direction, hence it is a vector quantity. Speed is the rate of change of position, whereas velocity is the rate of change of displacement. Velocity is equals to displacement by time, whereas speed is equals to distance by time. So what do you mean by acceleration? Let us say the car was initially at rest, hence the velocity at initial position be 0 meter per second. So the car starts traveling up to certain distance and it reaches the final position. At final position, the final velocity of a car is 50 meter per second. So how do we calculate the acceleration? Acceleration is equals to change in velocity by time. Change in velocity is nothing but final velocity minus initial velocity. We know final velocity is 50 meters per second and initial velocity is 0 meter per second. So 50 meter per second minus 0 meter per second divided by 10 seconds. Acceleration is equals to 5 meter per second square towards east. But how do we define acceleration? Acceleration is the rate of change of velocity. Since we have a direction, it is a vector quantity and the SI unit is meter per second square. And also the most important thing we have to note here that the acceleration is positive since the velocity of the body is increasing. The car is moving at a speed of 50 meters per second. Suddenly the car encountered an animal. Immediately the driver applies a brake and the velocity of the car immediately becomes 0 meter per second. The initial velocity was 50 meter per second and the final velocity will become 0 meter per second. That means the velocity is decreasing. So this decrease in velocity is called retardation.